Also, boy is this a crack of a question. We've been given two solids, solid A and solid B, and we're told they're mathematically similar. Remember, all a solid is just a 3D shape, all right? And if it's mathematically similar, then we can imply that if solid A is a cube, then solid B will also be a cube. If solid A is a cylinder, then solid B will also be a cylinder, okay? We're then given some information that the ratio of the surface area of solid A to solid B is 4:9, and we're given that the volume of solid B is 405 centimetres cubed. And we essentially asked that, given that information, can we find out the volume of solid A? And we're given that it's a guide of 120 centimetres cubed. So if we don't get 120 centimetres cubed, we know we've gone wrong somewhere. Okay, so essentially what we've got is we've got a solid, or we've got two solids, but I'm just going to draw one of them. Okay, and then if we unpack that into the net of that shape, so you're happy that if we unpack it into the net, then we can just find the surface area, and we're given information about this surface area. And essentially what we're being asked is, given information about the surface area, can you rebuild this back into the original solid to work out the volume? Okay, so essentially what we need to do is form a relationship between just the length, the area of something, and volume. So let me try and show you. Let's suppose we start with a length. So a length is just a line, right? And let's suppose that length of the line is 5 centimetres, okay? Well, then using that line, we can build a two-dimensional shape. So in other words, we can form an area. So we just put those four lines together like that, okay? And this is 5 centimetres, this is 5 centimetres. Happy I've just formed a square there. So what is the area of that shape? Well, it's 5 times 5. Well, I can write 5 times 5 as 5 squared. So 5 squared, centimetres squared, right? Centimetres squared. Okay. And then I can equally use that line to form a volume as well. So a three-dimensional shape. All right, so like that and like that. And so this is 5 centimetres, this is 5 centimetres, 5 centimetres. So what is the volume of that shape going to be? It's just going to be base times height times depth, which is 5 times 5 times 5. So that's 5 cubed centimetres cubed. Okay, so this is actually 5 centimetres. Okay, so what's the relationship between length, area and volume? Well, we can say then that in order to move from length to area, all we have to do then is square. Because you can see we started from 5 and we moved to 5 squared, all right? If we then wanted to move from length to volume, all we have to do is cube. Because you can see we started with 5 and we ended with 5 cubed, all right? So now we've formed this relationship, can we sort of work backwards to find what we need to find? So let's suppose we start at any point in this kind of three chain, if you like. Let's suppose we start at area, okay? Can we work from area to volume? Well, yes, we can. Because if we start from area, okay, we just go back to length, because we know the opposite process of squaring something is square rooting something. Okay, square root. Okay, the reason why I square root is because in order to get from length to area, then I have to square. But if I want to start from area and get back to length, I'm going to have to do the reverse process because I'm going backwards. So it's just square root, okay? And then I just cube whatever that length is to get back to my volume. Okay. So now let's go back to the information in the question. I've been told that the ratio of the surface areas of the two solids is 4:9. Well, what does ratio mean? So I've got solid A to solid B, so the area, the surface area, or just area, of solid A to solid B, okay, is 4:9. Well, that means that I could just take it on face value. So I could just take that the area, the surface area of solid A was just 4 centimetres cubed. 4 centimetres squared. And equally, I could take the surface area of solid B just to be 9 centimetres squared. As long as they're in the same ratio, it doesn't matter. So you're happy that I could just take those numbers. Okay, so let's say, for example, that the surface area of solid A was 4 centimetres squared. So if the surface area of 4 centimetres of solid A was 4 centimetres squared, so I'm currently sitting here in my chain, I want to then move from there to volume. Okay, so if I move from there to volume, I'm going to have to square root to take it back to length. So what's the square root of 4? Square root of 4 is 2, so that's my length now. That's my length. That's my length. Okay, but then I want to move from my length to my volume. How am I going to do that? I'm just going to cube it. So I've got to do 2 cubed, and that gives me that gives 8. So that gives me my volume. Okay, so I know that my volume of solid A was 8. I should really write 8 centimetres squared there, shouldn't I? So 8 centimetres squared. Sorry, I meant centimetres cubed. So this is 8 centimetres cubed. Okay, so that's the volume of solid. Then I just do exactly the same thing for solid B. So I've said that my surface area is 9 centimetres squared. So currently I'm sitting here in my chain. So 9 centimetres squared. Okay, so in order to get then the volume, I need to work backwards. So I need to square root 9 to get to my length. So square root 9 is 3. So that's equal to my length. Okay. And then I need to cube that to find my volume. So what's 3 cubed? Well, that's 3 times 3 is 9. And then I times by another 3. So that gives me to 27. So 27 centimetres cubed is my volume. Okay, so 27 centimetres cubed is my volume of B. So now I can form a ratio. So I can say that the ratio of the volumes for solid A to B, so A to B, was just, well, 8 to 27. 8 to 27. Okay. So now I've been given that the volume of solid B is 405 centimetres cubed. So in other words, I know that the number that I want to put there is not 27, but 405. Okay. And then that will allow me to find out what number should go here. Because that will give me then the volume. This will give me the volume of solid A, this volume which I'm after, because it's now just a case of working with the ratios. So if the volume of solid B was 405, okay, at the moment I've got 27 in my ratio. I've got 27 in my ratio. So in other words, what I want to do is I want to see, well, what's 405 divided by 27? Because at the moment, you know, I don't want 27, I want 405. So how many 27s fit into 405? So I'm essentially trying to do this arithmetic in my head. That looks quite difficult, doesn't it? But okay, I'm just going to set it up how I would normally. So this is 27 here, divided by 405. 405. So how many 27s go into 4? None, so I carry the 4 across. How many 27s go into 40? Well, 27 times 2 will give me 54. So that's already too big. So I know that I can only fit 127 inside 40. But how many have I got left over? I've got 13. So what's 27 divided by 135? So how many 27s fit in 135? I think there's only one way for it. I'm just going to have to write down. 27 times 1 is 27. 27 times 2 is 54. I can get to the answer quicker by saying that 27 times 4 will just be double that, right? So double that is just going to be 108. What happens if I add 27 to this? Add 27 is going to take me to 135. So I know then immediately that 27 times 5 is equal to 135. Okay, so 27 times 5 is equal to 135. So I know that that becomes then a 5 there. So 15 times 27 will give me 405. So I can say that 405 divided by 27 is 15. Okay, so actually I've got 15 here. So that's per unit in my ratio. But then what I'm going to have to do is then multiply that by 8. So each unit in my ratio is worth 15. Okay, but for volume A, I want 8 of those units. So it's going to be 8 times that. So 8 times 15. 8 times 15. Well, 8 times 10 is 40. 8 times 10 is 40, but then I'm going to have to plus on 5 times 8. 5 times 8, I know that. I know my times tables. That's 40. Sorry, I did that wrong. 8 times 10. Let me do that again. Sorry. 8 times 10 is 80. Okay? And then I'm just going to have to add on 8 times 5. Well, 8 times 5, that's 40. So this comes then to 120, as expected. So therefore, volume A is 120. Okay? So it's quite a difficult question. But actually, if you just break it down, form that relationship between length, area, and volume, it's straightforward. Hopefully you followed that.